All right, guys, we are talking, again, let me try to reiterate what I just said earlier. You've got to know this. You've got to know this. You've got to know this, what we're doing today. This is one of those things you got to know the vocabulary and everything, especially for standardized tests. And it really does help if you know it. All right, who can tell me a definition of isosceles triangle? What do we get for an isosceles triangle? Yeah, Holly. Yeah, it's a triangle with at least two sides congruent, which means you can have how many sides congruent? At least two, but that means you can have what? Three. So we know then that all equilateral triangles are also considered to be what? Isosceles. So make sure you know that. Now, we have different parts of this label, and it helps us define things a lot quicker on isosceles triangles. So first of all, the two congruent sides, those are actually called the legs. So these of them are called the legs. So just like remember when we talk about right triangles, we had the legs of a right triangle as well. We have with isosceles triangles, those are also called the legs. So if they're congruent to each other like that, they're called the legs. The angle that is formed by the two legs, so this angle right here, that is called the vertex angle. So the vertex angle is always going to be formed by the two congruent sides on an isosceles triangle. And then, actually I'm going to go like this to make sure we have a label. Here's vertex angle. Don't label that vertex, because how many vertices does that triangle have? 3. So make sure you say specifically vertex what? Angle. Just so you know, a little difference in notation and things. The side that we don't have labeled yet is the one that's always opposite the vertex angle, and that's called the base. And what kind of makes sense, it would be kind of like the bottom of the triangle. If we always assume the vertex, we don't assume the vertex is the top, but like if you was to turn that isosceles triangle around, the vertex would be at the top, the base would be at the bottom. So the side opposite is always the base. Now, we still have two angles we have not talked about yet. Okay, we have the vertex angle, the legs, the sides. We have two parts of that triangle we've talked about. And it's the two angles 1 and 2. Those are called the base angles. They're just the angles formed by the base. Notice they're consecutive angles that share that common side. So you can say the base is included between the base angles is another terminology that you could use for that. So you have to make sure you have all of those parts. All of those parts. Now, the next two actually have names to these, but again, it's one of those that if you know them no matter what, it's going to make your life a lot easier. I was just doing an ACT review with my pre-cal students, and they had to know this theorem. It was a big deal that they know it. So what is this first theorem? It says the isosceles triangle theorem. All right, it says the following. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So the angles opposite those sides are congruent. Now, let's do a quick refresher. I'm not sure if I've ever truly said this. Have I ever really explained to you opposite angles, opposite sides yet in here? I don't know if we talked about that yet. So let's go off, take a little sidebar here. Guys, just draw a triangle, and let's label it. Let's keep it simple, because you know how, let's do triangle dog. It's a little more fun. All right, I have triangle dog right there, okay? We need to understand what it means, opposite sides and opposite angles. If I'm talking about angle D, it is opposite segment OG. It's always opposite the side that doesn't make the angle. Notice the other two sides of the triangle make that angle. And then angle D will be included between them. So basically it's the non-touching side. Now this is, I'm talking about triangles strictly on this, okay? So when you're talking about it. So when I talk about an opposite angle and opposite side, they're the ones that don't touch. So think about this, guys. Angle O is going to be opposite which one? Yeah, opposite segment DG, right? And then we'd sit there and say, okay, segment OD is opposite what? Angle G, right? So that's the idea of opposite angle and opposite sides. So when you're looking at this one, it says, if the isosceles triangle theorem says if two sides of a triangle are congruent, then it's the angles opposite those sides are congruent, which means these two would be congruent to each other. Here would be the opposite side, and that would be with the opposite side. So they're using terminology. Now, guys, what do we call those angles? What do we just label those angles up above on that first triangle? We call them what? Base angles. Is there another way I could word this very short and sweet? It says here, if two sides of a triangle are congruent, right away that makes it what type of triangle? Okay. What angles on the isosceles triangle are congruent? Base angles. So another way that you can actually say that is right down here. So if you ever say the base angles of an isosceles triangle are congruent, that means the same thing as what we just wrote down in our theorem. The reason why they don't say that every single time is because if I have an equilateral triangle, guess what's going to happen to all my angles? They're all going to end up being congruent. So that's why they just talk about opposite angles and opposite sides when they're doing that. But the cool part about it is if you understand the isosceles triangle well, you should always be able to mark up your base angles very quickly, and you should know that they're congruent. But then we also have the converse of this. So the converse of the isosceles triangle theorem says, instead of starting with the sides, we're going to start with what are angles, right? So it says here, if two angles of a triangle are congruent, then the side opposite those angles are congruent. So now it starts out just the converse of what we're doing. I have those two lovely angles marked, which means automatically I know this side and this side are going to be congruent to each other. Now, what? Yes, please. All right, you don't even have to ask on that one, Katie. I'm good with that. Anytime you need to. All right, so make sure you have these. I don't mean to be like over hyper crazy. Just memorize it, please. Just memorize these two by heart. Know them well because you're going to apply them till the end of the year. It's just one of those time saver, huge ones that we're going to have. We're going to prove the isosceles triangle theorem in just a little bit, but we're going to get some of our other theorems down first. All right. Remember the idea what a corollary is? A corollary is still just a what? It's still a theorem, but it's a theorem based closely off a previous one, right? So remember, corollary is just a theorem based closely on another one. So remember, corollaries are just theorems. So I'm going to give you two corollaries that I think you already instinctively knew, and I've even implied to you before. It's the following. If a triangle is equilateral, what does equilateral mean, guys? Yeah, all sides are congruent. Awesome. So if all my sides are congruent, then it is equiangular as well. So notice my little shortcut way of writing this down. If I was ever doing this on a proof, I would just do the shortcut. If it's equilateral, then we know it's equiangular. Now guys, think about the common sense behind this for a moment. Let's apply the isosceles triangle theorem to this. The isosceles triangle theorem said, if I have two sides congruent, what do I know about the angles opposite them? They're congruent, right? So I picked those two sides, but don't I have another two sides I could use? Like maybe these two are the two I'm going to be using, right? Well, if they're congruent, what do we know about their angles? They're congruent. Oh, look. Do I end up having three congruent angles? Yeah, so basically just using what we know, we can show that all three are the same. So think about it. Didn't it always look that way? If you draw an equilateral triangle right, doesn't it always look like it's equiangular? Because it is. It always goes that way. Yes. Not unless you know the measure of the angles. If they're 60, yes. If they're not 60, no. Yeah, good thing on that one. All right, now guys, now you apply the converse. We're going to go the other way around. If all the angles are the same, what should I know about all my sides? If they're going to be the same way. So matters where your start or ending is on this one, but it goes pretty well. So on this one it says, if a triangle is equiangular, then it is equilateral. No matter what. It goes the other way around. Guys, it's one of those common sense things. If I ever gave you, in fact, I have an equilateral triangle, what are you going to tell me the measure of all the angles are going to be? 60. Please use that to your advantage. Okay, use that to your advantage. But I also want you to think about this. This tells you something about how angles and sides of a triangle relate. Does the size of the angle make a difference on the size of sides of the side? Wow. Oh, getting choked up about that. Not really. All right, anyway. Think about, here's my hand, and I have an angle here. Magically, between my fingertips, I've got my third side. If I make that angle smaller, what happens to that side? Smaller. If I make the angle bigger, it's what? Bigger. So we naturally, instinctively know bigger angles have bigger sides opposite them, right? So think about it. If you have angles that are the same size, shouldn't the sides opposite them be the same size? So really, it's kind of an instinctive thing that we kind of need to know. All right, now let's actually prove this, okay? Let's prove the isosceles the triangle theorem. Wow, great time to be recording. Oh, can't talk. All right, you're given, okay, basically, not even saying it's an isosceles triangle, you're just given two congruent sides on a triangle, all right? We're supposed to somehow show that the base angles are congruent. We want to show angle B is congruent to angle C. Now, here's the first thing you need to remember. You can add stuff in once in a great while with proofs, because remember, they're there, we just haven't ever said it. So this is one of those where one reason why we're proving it together is I don't want you to have to worry about if you have to add in something or not. But first thing they did is they put in a midpoint, right? If I put in a midpoint, you get to what? So we're going to have to put that somewhere in our proof. Those two are going to be the same. Then I'm going to draw in an auxiliary line. Remember, auxiliary lines are ones we add into proofs. So we make, and so we're going to add it in that goes from our vertex angle, A, straight to my midpoint. Now, guys, the moment that I do that, how many triangles did I just form? 2. Okay. So remember, we're going to get 2. Now, let's go ahead and put our stuff through on this one, all right? So you're given the fact, actually, let's just keep going on this one. Guys, if I draw in a midpoint, what should you have? If I give you a midpoint, what do you give me? So shouldn't I put those down? I have a mark. Shouldn't I put them down? All right, so let's put them down. So I got segment BX is congruent to segment CX, and that's just definition of a midpoint. Awesome. Can I go back to my given now and say AB is congruent to AC? Have we even used that yet? It's marked, so we probably should put it down. So we got segment AB is congruent to segment AC. And that's given. All right, guys, look, I'm labeling one side of one of my triangles. I have a side. I need a third thing. What can I show for my third thing that's congruent? Side, yep, reflexive, right on. Good job, guys. So we know now segment AX is congruent to segment AX by the reflexive property. What do we know about our triangles? They're congruent. So I got triangle, let's go ABX is congruent to triangle ACX. And that's going to be what reason, scholars? Side congruence. Awesome. Now remember, what am I trying to prove? I'm really trying to show that those base angles are congruent. Well, what's so special about those base angles? Are they corresponding angles? So can I use one of my favorite theorems? What is it? Which means what? Go.
Corresponding parts of congruent triangles are congruent.
Not passionate enough, but good. All right, that was good. At least you guys were doing it for me. Now, do you see how that will always work? But you did have to know congruent triangles or this wouldn't work at all. This wouldn't work at all. All right, let's keep on going, my friends. Making sense so far? Excuse me, Katie? No, this was just doing a proof of the isosceles triangle theorem. So we're just proving the theorem. That's all we were doing. We were just proving it. All right, now let's have a little bit of fun with this. So anytime you see stuff now, you have triggers that should help you solve for different parts of triangles. So like on this very first one, it says, I want to find the measure of angle N. What do you have marked though? You have marked the sides are congruent. But if you know the isosceles triangle theorem, what else do you know is congruent? The angles, right? So the fact is, if those two sides are congruent, we know these two angles are going to be congruent to each other. And now it's going to be easy for us to go ahead and solve for the variable and then for the angle. So I get here 6y equals 8y minus 16. So I'm going to move the 8 over. So again, negative 2y equals a negative 16. What's y going to equal, you guys? Bless you. It's going to be 8. All right, are we done? No, because that's not where we want to go. We want to find the measure of the angle. So we have the measure of angle N is equal to just 6 times 8, which is how many degrees, scholars? 48 degrees. Good stuff. All right. Are you guys ready to try some on your own? I'm going to let you go cold turkey for just a few minutes trying on this. All right. I want you to do just the first two. Just do 3 and 4. Don't work ahead. Just do 3, 4. So I'm going to pause the video for a moment so you guys can try it before we do it together as a group. Right? On the first one, guys, the very first two triangles, the reason why we're talking about these, 3 and 4, are those right triangles. Are they also marked with 2 congruent sides? There's a name for that, and it's a name that gets used a lot in geometry. They're called isosceles right triangles. And right away you can picture it. You have your right angle, and then the 2 legs of the right triangle are actually congruent to each other. So using what we know, we should be able to find the measure of angle x pretty quickly. Because what do we know about x and z? First of all, we know they're congruent because they end up being base angles of an isosceles triangle. But we also know, since that's a right triangle, those 2 angles have to add up to how many degrees? 90. So how can I quickly solve for x? How would you do that real quick? Divide by 2. So can I just sit there and go, all right, 90 divided by 2 is 45 degrees. Now, here's the thing. Anytime you see the word isosceles right triangle, you should actually know that those 2 acute angles are how many degrees? 45. So again, we're going to do a lot with that second semester, but this is really precursor. This is where it's all coming from. But you should always know they're always 45 degrees. Now, on the next one, is that still an isosceles right triangle? Now, and again, this is review. I'm not, okay, to be honest with you, I'm not going to ask this on your test. If I do, you can come back and get me one, all right? You should know how to solve for the missing side of right triangles. Remember what theorem you used to use? Starts with a P. Pythagorean Theorem. So anytime you have a missing side of a right triangle, and you know 2 of the other sides, you can use the Pythagorean Theorem to help you. Now, some of you would tell me the Pythagorean Theorem is a squared plus b squared equals c squared. Throw that out. That really is just because they use those variables. It's not because it means anything. Really what you should remember with the Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared. So you know they're links. So when you're working with it, we're just going to use the Pythagorean Theorem on here. You're going to go 1 squared plus 1 squared equals the hypotenuse squared. So leg squared plus hypotenuse squared. This is where the math is rough today, people. I'm just telling you, okay? So you have 1 plus 1, which is what? I know, math is rough. Ugh. Oh, let's go back to what we had on our quiz the other day. I'm solving for x squared. What do I need to do to both sides? Square root it. A little bit more here. Plus or minus. Thank you for the enthusiasm there, Getty. I appreciate it. All right. Plus or minus the square root of 2. Now, remember, everything's about context, though, correct? In the context of this problem, are we going to have a negative length of a side? No. We know if we're solving the problem right, you can come up with possible 2 answers. But in context of the problem, I can only use which answer? The positive. So the length of that would be the square root of 2. So make sure when you're looking at stuff like this, my friends, that you are actually thinking through context. Now, work-wise, do I still want to see all this work? Yes. In fact, I'm one of the few teachers that will ever make you, when you're using the Pythagorean Theorem and you're for sure using it for the Pythagorean Theorem, that I still make you put the plus or minus there because you won't remember to do it next year if I don't make you. It's one of those things that you have to know. All right, now let's look at the next one. Let's look at number 5. Guys, what's so special at number 5? What do you see given to you right there? Trevor.
It's equiangular.
It's equiangular, which automatically means what? As equilateral. So the very next thing I'm going to do is mark all my sides congruent. Now, I'm looking for the length of segment PQ. What do I do next? Yeah, set the two I know, right? Equal to each other, because I know if I can solve for one of them, I know I have PQ is going to be the same. So we set them equal to each other. So I get n squared equals 3n plus 18. Now what, scholars? All on one side. You have an n squared and an n there. It should be screaming at you, probably a factoring problem. It's a quadratic. So we go now, n squared minus 3n minus 18 is equal to 0. Well, we're just going to be factoring now. In fact, I'm going to move this up a little bit higher so I have a little more room on my paper here. All right, so I get my 2 sets in parentheses because there is no greatest common factor this time. What are my signs inside my parentheses? Plus and minus. Very good, Luke. Awesome. Plus and minus. So I have an n and an n. Now think about what two numbers multiply together to be 18, but their difference is going to be 3. 6 and 3. Where are you putting the 6? Where are you putting the 3? Yep, 6 and negative 3. Awesome with this. All right, now what do? We're going to have to go ahead and finish solving, right? You got n plus 3 is equal to 0. I get n minus 6 is equal to 0. I get n is equal to negative 3, or n is going to equal to a positive 6. When you have two answers like this, context of the problem requires us to check to see if they both could work. Right? We have to check to see if they both could work. Now, the cool thing is, n squared, we know, is going to come out positive. So I'm not going to actually use that one to check. I'm actually going to use segment PR's length to do that with us. So you could literally say, okay, segment PR, which, by the way, is equal to what? PQ. So I'm really doing two things at one time, which makes life so much nicer. So what do? We're going to go, all right, if I go 3 times negative 3 plus 18, what do you get? Do we get 9? So is that okay answer? Is it a positive length? So negative 3 actually works this time. Oh, what do you mean it's not congruent? Well, what's a negative 3 times negative 3?
Oh.
Yeah, so it does work, right? So it does work. So that way we know if they're both 9, PQ has to be 9. But using the same type of idea here, I got to plug in my other one. Well, 3 times 6 plus 18. Isn't that 18 plus 18, which is what? 36. So in this case, how many answers did I actually have? 2. Guess what? 2 answers are okay. We can't do any more than that. We've got down on what we have. So is factoring still a viable option? What if I plugged one of them in and it didn't work? So you just ignore that answer. You cross it out and it's called an extraneous solution. So just remember, you got to check. Geometry requires, even actually a lot of algebra questions do, is this the correct context of my answer? Does this work? Make sure that we have it. All right, number 6. Talk to me. I'm looking for the measure of angle K. I'm looking for the measure of angle K. All right, Cora. So I got vertical angles, so I know those are the same. Awesome. So I got, there's 28.
And then the base angles are
Yeah, exactly. The base angles are correct. So here's an easy way of doing this. Guys, I would actually just call them both x if that's the case. And can I just go 2x plus 28 is going to equal how many degrees, scholars? 180. That's just using our triangle angle sum theorem, correct? So if I do that, I get 2x is equal to, I do believe, isn't that going to be 152 degrees? Double check my math though, friends. 152, so x is going to equal 76. Because I divide both sides by 2. Now, out of curiosity, what should angle I and angle J both measure? Do you think they both measure 76 as well? You can't say that though. Why? We don't know if it's isosceles or not. So Don't get sugared in. It's like, oh, yeah, this should match right away. No, I don't have enough information for the smaller triangle to help me out. All I knew was the vertical angle. I would have to know if the sides are congruent or not to go further. Great. Glad you guys saw that right away. All right. I don't know if you guys could see this one very well, but that's a 30t, and that should be a addition sign on there. Did it come out at all on your? No, it doesn't always come out well. All right. So what are you going to be doing on this one? So got 30t plus 20 is what that should be. What do you know, guys? What do I have? Hannah, help me out. What do I know about that triangle? Yeah, it's equilateral. So right away we can assume everything is equiangular. And we learned our very first day in this class, if you have an equiangular triangle, what's its measure of its angles? 60. So that's all you have to do, my friends. Just go 30t plus 20 is equal to 60. Because we know all of those are going to be 60 degrees. So 30t is equal to 40. So t is going to equal to 40 over 3. How should you give me your answer? Leave it as an improper fraction. You do not need to do any more than that, as long as it's in simplest form. It's been reduced completely. Again, all you do, anytime you do geometry, let's think about this. Don't you look and say, what am I given? What information do I have to start with? And then you go like, oh, I now can apply this. It's really very much law of attachment. If this happens, then I know to do this. It's really the same type of process with these. All right. Looking at the next one, suggestions on how I can solve for n. All right.
Oh, you know that angle S.
Beautiful. I know angle S is congruent to angle T by what theorem?
Oh, isosceles.
Yeah, the isosceles triangle theorem, because we know the base angles of an isosceles triangle are going to be congruent. So I can go ahead and label that information, if I can draw it correctly, 3.5 n degrees on our triangle, correct? Then do what? Yeah, add them up to 180, because we know our triangle angle sum theorem doesn't change. So 3.5n plus 3.5n, or you could go 2 times that, I'm good with that, plus 11n equals 180. So guys, did you guys get 18n equals 180? N is equal to 10. It's kind of fun, isn't it? Okay, I think it's fun. I enjoy it. This time it says find the measure of angle A. I'm going to let you guys try it. My one hint is mark in everything you what? You know. So go for it. You try A on your own first. The last problem for you, it's not moving. There, it worked. All right, right there. Did that help you out, Anna? All right, guys. On the problem I just had you working on, what did you mark in the triangle on the right, the small triangle on the right? What did you put it all in there? They're all how many degrees? 60. Yeah, they're all 60 degrees. So when you're working with that one, that's the first thing you should have been doing. Oh yeah, I know it's an equilateral triangle is equiangular. The moment you do that, do you agree with me? I know what angle ADB is going to be. Is that going to be a linear pair? So if I'm looking for the measure of angle A, I know it's base angles of this isosceles triangle. Could I basically go 2x plus 120 is equal to 180? And I'm just using the fact that two angles measure the same. So I get 2x is equal to 60, x is equal to 30 degrees. And since I defined my angle A as x, I got a 30-degree angle. Does that make sense? Yes? No? And nods? Okay, good. That one, the best thing you do is just start marking in everything you know. Just mark it in, mark it in, mark it in. The linear pair, or you can say the exterior angle of the triangle. How do you get what? Linear pair. That, or you could use also, here's your remote interior angles. That would be your exterior one. So the two remote add up to the exterior. That's another way of doing that one. All right, let's look at this one. Again, what would be the wise way of doing this one? Putting in everything you want. You know, and the bell's going to ring, but I want you guys to wait until we finish it, okay? So with this one, do you guys agree with me this is true? Could I call this like W or something like that and solve for W? So if I do that, I get 2w plus 76 is equal to 180. 2w is going to be 104. What's w going to be? Guys, 104 divided by 2. Thank you, 52 degrees. So I know this is 52 degrees. Can I do the same type of idea for the other triangle? I'm just going to call those y this time, okay? Well, I get 2y plus 102 is equal to 180, because again, I had these isosceles triangles, base angles are congruent, all the angles of a triangle add up to 180. So I get 2y is equal to 78, y is going to equal 39. All right, guys, before you leave, remember I asked you to stay with me here. What do I do now to get x? What do I know? Can I use sum of the parts equal the whole? What do they add up to? Yeah, I'm going to go from here to here. So I know x plus 52 plus 39 is going to equal 180. And the cool thing is you just add them together.
Please come to the front office. Also, Joe Birchfield, please stop by.
And solve for it. You're going to get x is equal to 89. So on homework, for homework, hints, if you're stuck, redraw your diagram and put in everything you want. Everything you know. Well, have a great weekend. Stay safe and out of trouble.